array can store a individual item, okay, but the thing is, right, array got its limitation, okay? Array got its limitation most of the time. In case you have forgotten what is array, right, let me remind you again. Example, this is an array size of 3, okay? Your array can store 3 items. When we are dealing with array, right, we are starting from index 0, okay? Always remember, our array is starting from index 0. So this is index 0, this is index 1, this is index 2. Refresh your memory only, okay? Refresh your memory only. This is a particular reason why our index is starting from 0. Behind the scene, right? Behind the scene. When you want to initialize an array, okay, you will tell the operating system what is the size you require. Then the operating system will go and find a memory, okay? You go through your memory. Your memory have a memory address one. Okay, when the operating system found there is a 3 space available, it must be continuous, okay? It must be continuous as you see in this picture. When the operating system see there is 3 empty space, right? Then the operating system say, okay, you can go and use this space, so you can start using it. And to tell you a bit about UCP, Java, right? Java only memorize this address 0x02, okay, 0x02. When we want to store an item, okay, when we want to store the item back to the memory location, right? How are they dealing with? Okay, to tell you simply, we are just using the index passed with the number, okay? Example, I want to access element C. How do I do it? I use array index 2. Usually it's like this, right? The 2, as you can see in here, is the index number, okay? Behind the scene, okay? Behind the scene is Java would use 0x02 plus 2. That means the memory location is at 0x04. Then you can directly retrieve the data, okay? This is the reason why our array is starting from index 0. The advantage of array is it's very fast, okay? After you use the 3 cell, right, later when you want to expand, let's say I want to use index 3, okay? I want to use index 3 to store a new data. I cannot extend it anymore, okay? I cannot extend it anymore. Because why? Because the previous address, right, may be not available, okay? And the next memory address may be not available because occupied by other program. That's why this is a disadvantage, okay? Array size is fixed. You cannot just extend it. Isn't it nice if we can just pick one available memory address, store data, and then we pick a available memory address, store data, and then next time when the array is full, when we want to store data some more, we just find available memory address and then store data. Example, right? This is the RAM, okay? As you can see, 0x1, 0x2, 0x3, 0x4. 0x1 is not available. 0x3 is not available. 0x4 is not available. Similar to this memory address, okay? 0x0a is not available. So on and so forth, okay? These are not available, okay? When you want to store data, right, you just have to look for a new empty space, okay? So computer scientists think about this problem. Isn't it nice if we can store data inside, correct or not? The computer scientists propose a solution. He say, okay, what if after we store element A, we store another data, which is the next memory address, okay? The next memory address. And then after we store data B, and then, right, we store the next memory address again. Then after we store data C, right now it's full already, correct or not? Let's say I want to fill in a new data, okay? I want to fill in a new data called as D, okay, D. So what should I do? I go and open a new memory address, okay? I go and find a available memory address. After I found a new available memory address, what I need to do is, what should I do? I just have to store, okay? I just have to store the next memory address. Yeah, okay, this D. Finally, we store the head memory value, okay? We have a head class field. We store the head address as 0x02, okay? Okay, next time, when we want to get the first item, we just start from the head, okay? Start from the head. Then we know the value is A, For the thing you see in here, this is called as single-ended linked list, okay? This is called as single-ended linked list. So right now, we got the head, okay? We got the head, okay? Our head will have the address of the A, okay? The address of A, okay? Address of A. And then the address of A, right? This address of A, inside this cell, we have store the next, okay? The next address, okay? As you can see, there is a next class field, okay? This is a next class field. This next class field, you store, okay, another list node. We call this purple thing, okay? The thing you see in here, we assume, okay? Just assume this list node. This list node, right? We can store a value inside, and we can store a next inside, okay? There's a value, and there's a next class field. This next class field is for storing memory address, okay? This next will store the another memory address. Then store C, okay? This C have a next class field also. We store the next memory address like this. No? Our new list node will have a value of D. Okay. Do you know how to get this item? We start from the head. Okay, we get the next item. So long it's not empty. Not empty, we go to the next. Not empty, we go to the next. Not empty, we go to the next, okay? And then not empty, we go to the next. This next is empty, null mean empty lah, okay? Null mean empty. This next is empty, right? Then we know this is the last item. Okay, this process is called as traversing, okay? Traversing, okay? We want to use our linked list implement the stack. Let's say I have A, B, C, D. So to put it to the bottom, right? We want to put A first. We want to put B, C, D, like this, okay? So A go in first, B next, C next, D next. But when you want to take out, right? When you want to take out, you want to take out the D, okay? You want to take out the D, okay? If you use a linked list implementation, to get the letter D is so slow, okay? So slow. I cannot. I need a faster way. The computer scientist is so frustrated. What should we do about this? Can we do anything about this situation? The computer scientists come out with an idea. Okay, the computer scientists say, what if we just have another tail class field lah? Okay, we just have another tail class field. So our tail class field, we just store this address, okay? Our tail class field, we just store 0x1f, okay? So right now, if I want to, let's say I want to get the last element, okay, I no need to call from my head lah. I just call from my tail. Okay, remember you have a remove last. Okay, similar when you want to remove last, right? So what should you do? Okay, what should you do? You just start from the tail. You start from the tail, you go to 0x1f. You go to 0x1f. Oh, I have found the data that I want to remove. Then you can directly remove it. So with this, we have solved the first problem. Okay, we solved the first problem. The thing that you see in here, okay, the thing that you see in here is called as double-ended. Okay, double-ended single linked list because this is still single. And now, if I want to remove our D, I remove D, okay, I remove the D, okay, so that this 0x1f address needs to update, okay, update become what? Update become the C address, okay. I want to update become the C address, but I don't know the C address, okay, I don't know the C address, we met another problem, we don't know the C address. Sure, we can remove the D, okay, we can erase the D. But how to get back to the C, Computer scientists say, so we just store the previous lah. Okay, we just store the previous address the C, okay, the C, right? We just store the previous address okay? The B, right? Okay, the B, we just store the previous address With this, okay, with this, we get our double-ended doubly-linked list, okay? Now I remove the D. Right now, I know I can go to the previous. Okay, I go to the previous is 0x13, okay? So I know it's 0x13 lah, so I can update the tail address. Okay, I update the tail address, become 0x13 This is our new tail right now. So as you can see, right, when we update our tail, after we remove, right, there is one more thing we need to do, okay? There is one more thing we need to do. We actually need to set the C next become null. Don't forget, okay? The next is no longer pointing at here, okay? The next is no longer pointing at here. So what will we do? We want to set the next pointing at null. With that, we have only completed our linked list, okay? Right now, let's say I want to remove the last item again, okay? I want to remove the last item again. So I call from the tail again, okay? I call from the tail. 0x13, okay, I return you the value. The last value is, okay, what is the last value? The last value is C, okay, you can directly tell me, okay, the last value is C. Let me use an eraser, so you can tell me the last value is just a C, okay, so you remove C, okay, after you remove C, right, you want to remove this item, okay, when you want to remove this item, you want to do what, okay, you want to get its previous, okay, you want to get its previous, so you know this previous is 0x0d lah, okay, so this become 0x0d, okay, 0x0d, and don't forget our 0x0d next no longer pointing at 0x3, okay, no longer pointing at here, okay, so we need to point this at null, Okay, point it to null. With this, okay, with this is the rough idea of our double-ended double-linked list. Okay, so let's look at the condition. Okay, let's look at the condition. There are 4 things you need to write. Okay, 4 things you need to write to make your linked list useful. Okay, you want to write a very essential thing called as remove first and also remove last. Because these 2 items, right, will use by stack and queue. Okay, your stack and queue. Just like your undo button, okay, undo button. When you want to undo, and then you want to redo, right? You want to know what is the previous step. You want to know the next step. In order to traverse back and forth, right, you must have a link, okay, you must have a link. That's why, okay, right, our linked list is very useful in this type of task, okay? We want to implement the first function called as remove first, okay? Remove the first item and also remove last, okay? Remove the last item, okay? Last item. So when the list is empty, right? Okay, when the list is empty, it looks something like this, okay? It looks something like this. Remember, the head is null, okay? The head is null. If the list is empty, the head is null, okay? You need to take care of this condition, just like your single-ended one, okay? Your single-ended one is also like this. You need to take care of the condition, whether it's empty or not. Because why? Because if it's empty, right, we want to set our head to store the ListNode address, okay? Let's say I insert first number 1, okay? The number 1, right, insert also have a next and previous. This is your new node, okay? Your new node, right, you set the next. You set the new next as the head address, okay? The next, you set it to this direction, okay? This is what you're doing, okay? The new node, okay, the new node, right, you set the next as the head address. Okay, you set, because the head address is storing this one, remember? The head address is storing this one. So that we store the next as this one, okay, this address also. Okay, after you store this address, our head is new node. Okay, our head address store the new node. So we can move this, okay, we can move this. Our head store the new node. See, this is a single-ended linked list. You haven't done. For our double-ended linked list, we need to set this. Okay, you notice this previous is not in the right direction, right? What should you do? You need to erase this now. Okay, you need to erase this now. This previous, right, you need to make it point at here. Like this one, like this. Okay, this previous initially is pointing at now. Okay, when you done this, okay, after you done this step, right, only your linked list is complete. Whether it's empty or whether there is one item or whether there is multiple items. This is remove, okay, this is remove. Our insert is just empty, and also whether there is item. Maybe in the beginning you will feel hard, but when you draw it yourself, you will feel better. Okay, because it's drawn by me, so you didn't get it too much yet. But when you draw it yourself, trust me, it will feel better. Better you go home, try to draw the diagram by yourself. Okay.